On the bench today is a Phoenix CPS-10 power supply for the Commodore 64. I picked this one up on eBay some months ago after seeing Jeff Burt had done a video on one of these a while back. It's got a few features that I like. It's got some outlets on the back. It's fused. It's well ventilated, but it's also riveted shut. I could probably just turn it on and test the voltage and use it as is, but I want to open it up and take a look at the inside, give it a visual inspection. I don't know what the ratings are on this. I haven't found any specs on it to tell me how much current it's rated for and so on. So I'm going to drill out these rivets and open it up, take a look at the inside, see what I can see. One-eighth drill bit seems to be the right size. Hopefully I'm not damaging anything on the inside. Well, I've had a little bit of a chance to look around in here, and I was a little disappointed. The fuse here is 5 amps, and the mains wiring is 18 gauge, but this wire here is not 18 gauge. This is maybe it's 22, maybe 20. Probably technically fine for 5 amps, but not great. This wiring that feeds the Commodore 64 looks to me like 24 gauge, really thin. The switch here does have a 5 amp rating at 120 volts. At first glance here, it looks like the ground wires were cut off, and indeed there were some green wires on here that were cut off, but these straps here are tied to ground, and those are connected to the case. So the ground pin here is grounded through the case all the way back over to here, which then connects to the ground wire on the plug. These diodes here, these must be the rectifier diodes. A little disappointed to see how small they are. These look like 1 amp rated, but I'm not sure. This is the regulator chip. That's a Motorola 1723C voltage regulator. And this here, 2N3055, is an NPN 15 amp power transistor. I suspect that this resistor here is the current sensing resistor, and if I'm reading this right, that's 0.29 ohms. According to the spec sheet for that voltage regulator, 0.29 ohms should equate to about 2.2 amps until the current limit cuts off. These two resistors here seem to be controlling the voltage. This looks, there's a third hole right here that looks like this was originally intended for a potentiometer. And turning it on here, reading out 5.186 with no load. So this is probably perfectly fine to use as is, but I think I'm going to do some mods to it to make it a little bit more heavy duty. Well, while I had it apart, I did a quick sketch of the schematic. And what we've got is something in between these two here. You've got these two resistors here for a 5 volt output, but the output stage is controlled like this. This is a 2N3055, and this all looks very much the same except for here. And I've replaced all the AC wire with 18 gauge to match the mains input. I removed this super thin gauge power lead here and replaced it with something a little bit heavier duty. This is 20 gauge wire that I pulled out of this old power brick. I also put some heat shrink here on the fuse holder and on the switch. And what I'd like to do now is see if I can't wire in one of these. This is a cheapo Amazon special volt and amp meter. Maybe I'll mount it on the panel here, but first I want to wire it up and see if it works. The wiring diagram for this little meter here is not very detailed. This one's for two separate power supplies. We only have one 5-volt supply, so we'll wire it up like this. The load here means these two wires that run out to the 5-volt supply on the C64 connect up the yellow, thin red, thick red, and thick black. This DC supply represents the pins here on the board. Okay, I believe I have it wired up according to the way it should be. I've got my multimeter here in the current path to measure current here to see how it compares to that. So I guess I'll hook up the 64. I don't have a dummy load, though I really should be using a dummy load for this. Let's turn it on and see what we get. Of course, I have the power supply unplugged. Okay, smoke test. There are two adjustments on the back here. One to adjust the voltage reading, and one to adjust the current reading. Voltage dropped to 5.1, current's up to 0.9 amps. After some cutting and some filing, we've got a suitable opening, or at least I thought I did. Need to go a little bit deeper. I succeeded in cutting and filing this opening and added a little bit extra room here for the lid, so we should be good to go there. But I noticed these screws were digging into my workbench because there are no feet on this thing, so I need to add some rubber feet. I have everything wired in correctly, I think. The positive side of the supply connects to the red wire, the yellow wire, and the load. So we have red, yellow, and the positive side of the load here. And then the negative side here, and coming back from the load here. I put some heat shrink on here, but I'm not going to shrink it up yet because I want to separate these wires in a minute and calibrate the current. First, turn on the power supply. Then the 64. So far, so good. With the 64 turned on and the system under load, the readout here is 5.1 volts, and my meter says 5.159, so that's pretty close. The calibration adjustment on here won't go down any lower. Now I separated these wires that run to the load so that I could hook the meter up in series to measure current. And we'll see what we get. 64 is on and running, and we're measuring 6.32 amps on the multimeter and 6.5 on this little thing. So 6.1, 6.3, that's going up, let's go down. 6.1. That's close enough. It doesn't need to be exact. Mainly the idea is to be able to see if the amperage jumps up suddenly for some reason. A couple of sheet metal screws should secure the lid back on. There we go. And just out of curiosity, I want to see how much the current goes up after I plug in a couple of cartridges. And it did go up almost an amp there, dropping back down now to 0.9. Well, there you go. The Phoenix CPS-10 power supply modded with a volt and amp meter. That's it for now. Thanks for watching.